Hello, it's Keith here, and this is lesson 13 of the simple series of my 68000 assembly programming tutorials, and we're looking at the x68000 this week, and we're going to be looking at sprite clipping. Now, sprite clipping we've looked at on a bunch of the 6502 systems, and the Z80 systems are coming as well, but we're going to be looking at the 68000 systems this time, and we're going to be porting basically the same sort of algorithm to this system. Now, what this does is it allows us to take our previous Sprite example where we had a bitmap moving around the screen with the joystick, and our previous Chibico bitmap example showing a large bitmap, but now it can go partially off the screen on all sides, and we're controlling it with our joystick here. Now you can see here we can go off all of the sides of the screen here, and we're using an XOR sprite here, so we're actually drawing it twice to the same position to remove it. That's a nice simple way we can create graphics and allow us to remove them from the screen without having to redraw anything that's under the sprite or worry about sort of clearing the sprite out with any kind of blank area. So that's the kind of graphics we're using, and that's what we're going to be looking at today, this simple sprite clipping example that also includes some joystick code and the general setup as well. Now, we're not going to look at anything today except for the sprite clipping code and the updated bitmap drawing, so if you don't know how the joystick works, you don't know how to turn on your screen and things like that, please see the other episodes of the Simple series or the platform specific series where we've looked at that kind of thing in the past. It's just the sprite clipping we're looking at today. Now, first of all, though, we're going to need to discuss the logical units, because I just need to make clear how I'm working with coordinates in these tutorials. So let's go over to the theatre screen. Let's have a look at those logical units. So here is an image which is representing the logical units. Now, the problem I have with my tutorials is a lot of them are on 8-bit systems, and those systems are slow enough at the best of times, and they don't work very well with 16-bit numbers. So what I want to do is want to have my coordinates in a 0 to 255 range, which works fine on most systems, and you know the x68000 has got a 256 pixel widescreen resolution that I'm using. But the problem is, while that's all very well and good for showing objects that are always on the screen, if our screen is 256 pixels wide and it needs to be partially off the screen, we need some extra coordinates that aren't always visible. And so what I'm doing is I'm using a very simple logical unit formula here. So basically we've got our visible screen in the middle of the logical screen here, and then this area around that is invisible. But it's still going from 0 to 255 on the x and y axis. And so what we're doing is we're doing some conversion of our logical units to convert them to physical units. And the simplest way I'm doing this, being as my target screen is really a 256 by 192 screen, is I'm using 2 pixels per one logical unit. So our 256 by 192 pixel screen will become a 128 by 96 logical unit screen, and we position that in the center of the sort of virtual screen here. And so if we've got our Chibico bitmap drawn in this position here, you know, this would maybe 32 logical units across and something like maybe 150 down or something like that. But you can see that only part of it is on the visible screen, and so we will work out the cropping for this visible part of the object. So that's how we're using logical units to deal with working within a 1 byte parameter, but allowing for a visible area and an invisible area within that range of numbers. Okay, so that's the theory of our logical units. Next, let's discuss the concept of how we're going to actually crop our sprites. So let's go over to the Blackboard screen. If I find the Blackboard screen, there it is. Okay, so I'm just going to very quickly discuss the sort of theory of what we're going to do to crop our sprites in these tutorials. And it's the same in all of them, but I need to go over it each time just because most people won't be watching all of my tutorials. So we've got something resembling a screen here. This is what I'm laughably calling a rectangle. And we've got some kind of sprite on our screen, which is always going to be drawn as a sort of box area. You know, whatever the shape of the sprite, we're always going to draw a box area containing it. So we've got our sprite here, and our sprite is going to move around the screen happily as it goes, but then, oh dear, it's gone partially off the screen, and we're going to need to recalculate things at this point. So the first thing we're going to need to recalculate here is we're going to need to change the height. The height will have changed to this. But the other thing is we're going to need to skip some of the source bitmap data. We're going to need to skip this part so that the first pixel we're going to draw is here. So that's what we would do if it goes over off the top of the screen. What if it goes over the left-hand side of the screen? Well, things are going to be a little bit different. We're going to have to skip this part of the sprite before we start drawing. We're going to need to change the width to this, but then after each line of the sprite, we're going to need to skip part until we get to the next line to continue our drawing. So that's on the left. On the right, procedure's different again. This time, we're going to need to change the width we're not going to need to change the starting draw position because we're drawing the first pixel, but we're going to need to skip a bit after each line. And if we go off the bottom of the screen, well, in this case, this is the easiest one, we're going to just need to change the height. We're just going to need to change the height so that we don't draw the bit that's not needed down here. Now, that's the theory on all of the sides, but of course, our sprite could go over multiple sides at the same time, and we're going to need to do a combination of them. And fun fact, the Chibi Akuma's game on the Z80 systems couldn't do it right because my maths was quite terrible at that time. It's still quite terrible now, but it's slightly better, so I've managed to get a working algorithm today, and that's what we're going to be having a look at. So there we go. So that's the theory, and we're going to be looking at that in our code today. So let's go over to the code finally, and let's take a look. Okay, here's the code we're going to be working with here. So this has been converted from originally the Z80 systems, and it's also been ported to the 6502. Now here at the start of our code here is the definitions of the logical units here. So we're defining a minimum visible pixel, and this is the top left of our screen that's visible. That would be somewhere like that. And then we've got a width and a height here, and that's defining the amount of the area that is visible, and by adding the width and the height to the minimum we can get the logical screen. So this logical screen here is being defined by these here, and you can see that the minimum does indeed match here, although the height has changed because this system has a 256 pixel tall screen, which is very strange, but that seems to be what it has. We've then got some setup for our screen. We've got the reading of the joystick routines. As I say, we're not covering those in this lesson. They've been covered in the simple series in the past, so please take a look at that if that's what you need to know about. Okay, so we've got our draw player routine here. This is the start of the routine that's going to draw our sprite to the screen. Now we're using an EOR sprite here, which is XORing, EOR, the same thing. It's XORing the data from the screen with the new sprite data, and this means because it's an inversion, if we draw the same object to the same position twice, it will remove it. It's just a simple trick to allow us to remove the sprite more easily and just focus on the one thing we're really trying to do with this tutorial. Now we're loading the address of the source bitmap data, that's our chibi code character, into register A6 here, the address register, that's the source data. We are loading the X and Y position in D1 and D4. So they contain the X and Y position in logical units, remember pairs of pixels, and of course 0, 0 is actually off the screen because our visible screen is in the center of the logical screen. So we just need to bear that in mind. If we're drawing it 0, 0, we might not see our sprite. Our sprite is 48 by 48 pixels, but that's 24 by 24 logical units because remember they're pairs of pixels on this system. So we're defining our width and height in D3 and D6, and we're running a routine called do crop. This is the new routine that's going to handle the cropping of the graphic and updating the source data as required. Now, if the sprite is entirely off the screen, there's going to be nothing to draw, in which case the carry will be set on return. And if it's set, we're going to give up. Now the code that's actually going to handle the sprite drawing is pretty simple, so we'll just quickly cover it here. We've got a calculation get screen pos here. Now once the do crop routine has been executed, the return will no longer be logical units, it will be physical ones. Now we've got this get screen pos function which will calculate the destination VRAM address, and all it's basically doing is it's taking the base address of the screen memory, it's adding effectively the Y position times 1024 because the x6800 screen layout's a bit weird. It always is 1024 units wide, even whatever the screen resolution. We actually need to double the X position by shifting it to the left once, and then we're adding that to the screen base along with the Y position, and this gives us our VRAM destination. And then what we're doing here is we are basically transferring 1 byte from our source. Now we need to split that into 2 parts because each pixel, although only 16 colors, is actually in a different word of screen memory, so we're having to effectively split them up here, and then we are transferring the first nibble here and then the second nibble here, EORing them as we do. That's all basically the same as it was before, and then the only bit that's changed now is after each line we are potentially adding this sprite H clip, which may or not be 0, and that's for the cases where our sprite is partially off the left or the right of the screen, because remember we're drawing across and then down the sprite, but if our sprite's partially off one of the sides of the screen, we'll need to skip a few of the bytes before we start drawing the next line. So that's why we've got this sprite H clip here, which we're adding to the VRAM source after each line has been drawn, but of course it will be 0 if the sprite is entirely on the screen. We're then adding 1024 and repeating for each of the lines of our sprite. So that's how we're drawing the sprite to the screen and the get screen pos, which hasn't really changed a whole lot. The real crux of the work is being done by the do crop routine. As I say, we are passing an x and y position, a width and a height, and a bitmap source here, and this is going to do the work of calculating any changes that need to be made to that to draw the crop sprite to the screen. We're using registers D2 and D5 as temporary calculations, and at the start we're clearing sprite hclip as well, because that we're assuming will probably be 0 if the sprite is entirely on the screen, which it usually will be, I suppose you could say. Okay, so we're going to crop the top of the sprite. So we're going to consider the top of the sprite and see if it needs cropping. So we're moving D4 into D0. We're using D0 as our work register here. We're moving 1 byte from D4 into D0 here. We're then subtracting the minimum logical unit, and this will push our sprite up, effectively working out the position of our sprite relative to the visible part of the screen. So it will have gone negative if it's being cropped at the top of the screen. If it's not, then we're just going to skip to not crop here. If it is, then we are going to have to negate it, and then we're going to compare that now positive value, which is now the amount we need to remove, to the height of the sprite. Because guess what? Well, if our sprite is entirely off the screen, the amount to remove is the amount of the height of the sprite. In which case, we're going to jump to all off screen, which is going to set the carry and return. If it's not in the entire sprite, we're going to store that in D5 for later. That's the amount we're going to need to remove from the top. But we're going to also need to change our drawing position, because we're now going to need to draw whatever we do need left from 0 at the top of the screen. So we've now effectively converted that. We've now subtracted the minimum logical visible unit from the Y position here. So we're updating D4. We're going to convert it to pixels later. But what we're doing next is we're going to consider the bottom of the sprite. So we're now adding the height in logical units, and we're now comparing to the height of the logical screen here. And this is effectively going to see if it's gone over the bottom of the screen. So if we're somewhere like that, in which case we're going to need to crop again. If it's not gone over the bottom of the screen, then we can skip the next part. Otherwise, again, we're comparing to the height here, seeing if the amount we need to remove is the entire height of the sprite. If it's not, we're storing that in D2. So we've calculated the amount we need to remove from the top in D5 and the amount we need to remove from the bottom in D2. So what we're going to do now is we're going to add those two together, and if the result isn't 0, then we're going to subtract that from the height of the sprite, and this is calculating the new height of the sprite accordingly. Now what we need to do now, though, next is remove any lines from the top of the sprite, because if our sprite is at the bottom, we need to draw from the very beginning, the very first lines. But if it's over the top, we need to remove some of the lines, and that's what we're doing here. So we're taking D5 and we're converting that to a number of lines here, and then we're multiplying the width of the sprite in bytes by the number of lines here and adding that to the source address. Now this will effectively calculate the number of bytes we need to skip based on the lines that are off the top of the screen. At that point, we've now cropped the top of it and bottom of the sprite. We've done the top and the bottom of the screen. We're now going to deal with the left and the right. The procedure is basically the same though. So we're clearing D2 and D5. We no longer need the old values in there, and we're now going to do the same just for the left and the right. So we're loading the X position into D0 here, subtracting the minimum coordinate, so we're of the X line of the horizontal lit visible screen here, so we're subtracting that effectively, and we're going to see if we've gone over the screen, and if we have, then our sprite must be over the left hand side of the screen like that. It must be somewhere like that. Again, we're going to negate that. We're going to compare it to the width, and if there is nothing left, then we're going to give up, and because our sprite is entirely off the screen. Otherwise, we're going to store the amount we need to remove from D5, set our X position to 0, and update our X position here. Okay, so that's the left side. We're now going to consider the right side. So what we're doing here is we're adding the width of our sprite to D0 here, and then we are comparing to the width of the screen in logical units, and we're seeing if there's anything that we need to crop, and if not, we're going to skip the next part. But if there is, we're comparing it to the width of the sprite and seeing if there's anything left. And if we're having to remove all of the sprite, then we're going to jump to all off screen. Otherwise, we're storing the amount to remove from the right in D2. So again, D5 has now got our left and D2 has now got our right crop. So those two are our crops here. So what we're going to do now is we are going to take D2 we're going to add D5 and see if the result is greater than 0, in which case we need to crop something. Now, whether we're off the left or the right, we're going to need to skip some bytes before the next line of our sprite. So we're updating that sprite H clip here. We're then subtracting that amount we need to remove from the width, giving us the new width. And if D5 is greater than 0, we're adding that to our source bitmap, because remember, the D5 is the amount to remove from the left-hand side of the sprite. Now that's going to be 0 if we're over here, but if we go over here, then we need to miss our character Yume's face here. You know, if it's all the way over here, we're going to need to skip bits. So that's what we're doing there. Now, we've now calculated all of our crops. We've updated A6, our source bitmap. The final thing we are needing to do here is update and convert from the logical units that we've been working in so far into our byte, line, and pixel units that we need for our code. And that's what we're doing here. So here we are doubling the height. So we're converting this to lines. And then what we're doing is we're converting our X and Y position into pixels here, because that's what we need. Now we're leaving our width as bytes, because remember there's 2 pixels per byte in our source bitmap because it's a 16 color bitmap, so we're leaving that unchanged. And then the final thing we're doing here is we're clearing the carry. The reason we're clearing the carry is because we're telling the calling routine that there is something to draw. Now if at any point we were sent to this all off screen, then we're setting the carry, because in that case we need to tell the calling routine to give up, because there is nothing left on the screen. And if you remember when we did the do crop here, if the carry was set, we were jumping to do sprite abort, which is going to cancel the drawing. So there we go. So that's the end of this tutorial. Now, as I always say, you can go to my website and download the source codes for today's example and also the build scripts and try this out yourself. Hopefully you can have some fun with it. And as I say, you're welcome to use the source code in any way. If you use it as part of some commercial game, I very much doubt you can, but I'm sure if you manage to do so, you deserve the credit for it. So you're welcome to do that and make any money you can from it. Anyway, hope you've enjoyed this today. If you have, please like and subscribe. If you like the videos, YouTube recommends them to more people. And if you subscribe, it makes me happy and I make more videos. And if you don't, I cry myself into a desperate despair. Anyway, thanks for watching today and goodbye.